Hi there, in this video we're going to be solving a very basic optimization problem. In this particular question we're going to be finding the shortest distance between a point and a line. Now suppose we had the line y equals x minus 2, something simple like that. Now let's say we had the point, let's say 0, 3. So what is the shortest distance between this line and this point? So we're going to be using the distance to point formula, so it's going to be 0, subtract, then the x value squared, and you'll see what the formula is in the end. So it's going to be add, then the y value, and the y value is essentially the 3 right here. So 3, subtract, then some y value, then squared, and all of this is being square rooted. And if you solve this out, you would get a distance between the point and the line. So in this particular problem, we're going to be wanting to put everything under one variable here. So we're going to be wanting to get rid of this y value, and we can do that by noticing that y over here is equivalent to x minus 2. So if we just substitute that in, well, first off, negative x squared, or what would that be? Well, that's going to be positive x squared. So positive x squared add, and what's going to be inside here? Well, we're going to be having 3 minus then the y value, which we know is going to be x minus 2. So so that's going to be essentially 3 minus x, and then if you put the negative throughout everything to the minus 2, you're going to get positive 2. So it's going to look like this. And now if we added the 3 and the 2 together, we're going to get 5. So basically, it's 5 minus x. And because it's being squared, you have to multiply this twice, like that. And all of this, of course, is being square rooted and will equal d. We're just simplifying everything inside to make it easier when we take the derivative afterwards. Now let's multiply this throughout. First off, so that's going to be 25, and if you multiply over there, it's negative 5x. Do it again, another negative 5x, so that's negative 10x. And then we have positive x squared. And of course, we have another positive x squared over here. And yes, it's all being square rooted. Now these two here can be added together, getting us 2x squared. Negative 10x, then positive 25. All of this is equal to the distance. Alright, so let's go ahead and take the derivative up here. I'm going to actually change this to a better color. Why not this? Okay, so we have, so if we take the derivative of this, I won't go over how to take derivatives, but it's essentially going to become this, because you have to recognize that this square root value here, if you ignore it, you can also write it like this. 1/2, right? So when you're taking the derivative, a good way to do it is just writing it like this. Basically, it's the same thing there, like this, negative 10, then positive 25, and it's usually over 1, and then you multiply it by the derivative of whatever's inside the square root. So that's going to be, where's my cursor? Okay, so it's 4x, then, I think I forgot an x here. That would be negative 10, and then the constant is just going to be a 0, so let's just ignore that. So it's going to be multiplied throughout, and I'll just do that here, I suppose. It's going to be 4x minus 10, and let me just erase this here. We don't really need that. Okay, so we took the derivative. This is equal to the derivative of that distance formula we have down there. Now what we need to do is solve it for critical values. In particular, well, we're going to be solving it for 0, because if you look at the bottom, the denominator, you'll notice that it can't actually be solved for 0. And I can prove this by putting it into the quadratic formula quick. In particular, the portion that's inside the square root, because anything inside here can't be negative, correct? So if I put b squared, which would be the negative 10, so negative 10 squared, minus 4ac, so a is 2, and c is 25. And notice that this would be 100, and this would be more than 100. Since you're subtracting it, it's going to give you a negative value underneath, telling you that you can't solve it for 0 at the bottom. And so the reason I'm stating this is because I want to instead focus on the numerator of that function. And my eraser is not very good, is it? Okay, so the numerator is 4x minus 2. That can be solved for 0. And if you did that, you would get, well, you get 10, then divided by 4 would give you 5 over 2. So x would equal 5 over 2, or 2.5. But this is one of the, well, that's the critical value, right? but it's not the distance. We're looking for the distance between 0, 3, and this line here. And to find that, we're going to be putting this value here back into the distance formula we have. So what would happen if we did that? And just to save some time, all I'm literally doing is putting the x value here into every x value in this formula here and seeing what value it gets outputted. So it's eventually going to equal, well, basically it's going to be the square root of 12.5, which is a irrational number, so it's going to go on forever. It's easier to keep it in this form. So this is actually going to be the distance, the shortest distance between this line and that line. And I can prove it a bit further because, well, what is this value is precisely, or not precisely, I guess, approximately 3.5, maybe 3.54, roughly. It goes on and on and on. So if I were to actually graph all of this, what would that look like? And basically, this would be the line y equals x minus 2. And the point we're trying to find the shortest distance to is 0, 3, which would be roughly around here. And essentially, we're trying to find this distance here. So this distance right there. And according to what we found, that's roughly going to be 3.54. Now, if you look at roughly what this is, right here, this is a value of 1 because, well, the x value right there is 1, right? And it's going to be 1 here, 1 there. And essentially, if you used the Pythagorean Theorem, you could figure out what the diagonal distance would be. So 1 squared add, or I guess 1 squared add 1 squared is going to equal basically c squared, which means 2 is going to equal c squared, which means the square root 2 is the diagonal distance. And if you do that to this next portion right here, you're going to get square root 2 add square root 2, and then you're going to get half of square root 2 because it only goes through this one portion here, half. So square root 2 add square root 2, then half of square root 2, which is basically this. And if you actually did that, oh sorry, I guess that would be like that. And if you did that, you would get actually the same value right there. So we know we're right about this. I thank you for watching. If you have any questions, feel free to ask in the comment section below. And I do hope you're having a fantastic day, of course.